Today my topic is little different. It's not about for the society, it's about the chemical engineering. So I want to teach you how to design heat exchanger in 1 minute. Yes, you can design your heat exchanger in 1 minute. And this method is very simple. And as a chemical engineer, you know some of the basic equations. And when you use it effectively, you can design heat exchanger in 1 minute. So watch this whole video and understand how to do this design. Okay? And if you like my video, then subscribe my channel and click on the like button. And another thing, click on the bell icon so that you can receive my notifications whenever I upload my video on YouTube. Okay? Let us assume that you want to design a condenser for one simple distillation operation. You are using one solvent, that is alcohol, like let's say methanol, ethanol, propanol, anything, and you want to chill the vapors which are coming from the vessel, the reactor, vessel, tank, anything. So the first step is, whenever you want to buy heat exchanger, I mean in from condenser, you need one thing, and the person, the client, will definitely ask you one thing: what is the area of condenser, what is the area of that heat exchanger you need? So basically you need to find out the area of condenser, the area, the heat transfer area for the condenser, so that the complete vapors will be cooling down. So now see my tutorial. Now watch this carefully. You have to use this equation: m lambda is equal to u a delta t lm. Why lm? This is because of lmtd, logarithmic mean temperature difference. This is a simple equation for any distillation operation, and our pharma employees will be too much happier after this video, because in pharma there are some solvents which they use multiple times. There are some common solvents like methanol, IPA, then propanol, MEK, toluene. These are some common solvents they use in many different processes that conduct in the pharmaceutical company for the scale-up engineer. Now for this equation, you have to find out this A. So A is basically m lambda divided by u into delta t lm. Now to find out this area of heat exchanger or condenser in just 1 minute, you need these values. So basically there are some thumb rules. There are some thumb rules you have to use. Now use this m. This is actually m dot. This is the rate of, this is the boil up rate, and this you have to assume 100 kg per hour. Lambda for the alcohol, for the most common organic solvents, you have to assume this. This is the latent heat of evaporation. Lambda is equal to latent heat of evaporation. You have to assume this as a 300. There is one mistake. Not 300. You have to assume as 1200. This is the common figure I have found out. This is the average figure I have found out from the most common organic solvents. 1200 kilojoule on meter square into Kelvin. This U for any chilling operation, for any cooling operation, take this value as 300 kilojoule upon meter square into Kelvin. And this logarithmic temperature difference. You have to assume this. You don't, for to calculate this area in 1 minute, you don't have to go in that counter current equations for this Slalom grid. You have to assume, you have to take the average. Like if the chilling temperature is 10 degrees centigrade and your, like let's say methanol is 64 is the boiling point. So basically temperature difference is approximately 50 degrees centigrade. You have to take this 50 degree, and this actually this will be kilojoule upon hour into meter square into Kelvin, and this is hour. So now put these values in equation, like A equal to this 100 kg per hour into latent heat of evaporation 1200 kilojoule upon R meter square Kelvin. Then U is, you have to assume this 300 kilojoule upon meter square R Kelvin, and this. Now seriously, this is a 50 degree centigrade or 50 degree Kelvin, because there is a difference. Now in this equation, these are the common values for the most common organic solvents, for the like let's say alcohol. So take this. So this will be 400 upon, this will be 400, and this is a 50. And by this, oh, this will be 8 meters square. This is the area of heat exchanger you need. So tell your client, tell your fabricator that he will provide you one heat exchanger that will having 8 meters square of area. Now further we will dig into this. Let's suppose the fabricator will ask you, what is the length and diameter of heat exchanger you need? Length and the diameter of heat exchanger. And here most probably people always take counter current heat exchanger. So this will need certain assumptions or certain homework. Like if your plant having, this is the plant, this is one reactor, this is one vessel, this is one vessel, and only this much area is free, this much area is available to locate any equipment, and this is the area like 4 meter and this is a 2 meter, then your heat exchanger land should not go beyond let's say 3.5 meter, because there are some utility lines will be there. So tell your fabricator, I need length is 3 meter and this dia. Now for this dia you have to assume a pipe diameter, pipe or tube diameter, a tube inside the heat exchanger. That is the diameter you have to assume. Most probably people always take 3 by 8 inches of 0.75, 0.75 inches of dia of tubes, and from there A equal to pi dl, you have A, you have L, D, and this you have to multiply with N. This is the number of tubes. No, that this is not, I mean, you will definitely ask me that you have used so many assumptions, you have used the thumb rules here in this equation, but I assure you that when a person quickly asks you that what kind of area you need for your condenser, and you will not have all the data available, you will not have the data sheets available, then what will you do? You have to use this equation. And trust me guys, trust me, this is my experience. You can do, you can, whenever you use this equation, whenever you use these assumptions, the probability, I mean the chances, the accuracy will be more than 80%. to the practical area. And if you have certain doubts, then multiply this area into some contingencies, like 20%. 20% is excess you can take. So 10 meter square heat exchanger you take for a plant. I mean, this is the simple way to calculate the area of heat exchanger. If you need this Excel sheets, I mean, you will not need an Excel sheets for this. This is a handy rule. You have to calculate in 1 minute. But if you need the Excel sheets, then definitely you mail me. My mail ID I have provided in the description. Till then, thank you so much for watching my video. Bye.